Hello everyone, this is Shaksham Chauhan and we are going to cover our assignment of Skyfi Labs. So here we are going to discuss the prediction of prices based on the Boston housing, and after that we are going to obtain the curves. So in the first cell, as you can see, we are importing the NumPy, MATLAB load and pandas. After that we are going to import some functions such as the func animation, load Boston and other parameters of Boston. After that we are going to create the Boston dataset, and then we are going to create a function of keys of Boston dataset, and then we print the datasets. So here we obtain the dataset characteristics where number of instances are 506 and number of attributes are 13. As you can see here the attributes, so none of the attribute is missing. After that, in the next cell we are going to create a data frame, as you can see here, having the columns equal to Boston dataset dot feature names. After that we get the dataset having different outputs here and having the 506 rows and 13 columns. Then we are going to take out the output of the taxes. Here we get the output having up to 0 to 506. So here we are having the 506 rows. So from 0 to 505, which are completely 506 rows. Here the length is 506, as you can see there, and the data type is of float 64. After that we are going to get the target of the data sets provided by the Boston housing. So we just get the target is equal to create or data frame. Here we get the column equal to targets, and as you can see here we get the output having 506 rows and one column is, as you can see here, is a single column. In the above one itself we have the different columns. So next we are going to get the minimum values and the maximum values of the target provided with the data. After that we are going to concatenate the target value, and here the axis is equal to is given. After that we get the output here. As you can see, there is a target and there are the data sets, and the same we got the output, the 506 rows and 14 columns as you see in the above cells. Now we are going to describe it where we round off the values which are in decimal form up to 4. As you can see there, here is the 4 values are round off 3.6135 and 8.6015 and 0.0063. These are round up to 4 values. After that we are going to create some functions and use some sorting techniques also. We are going to plot here. So here we get the X label attributes and the Y label correlation with the target. And that way here we use a function for correlations of pairs and targets and attributes in the list. Here we get the graph. As you can see there, we have the different datas here having the different graphs. Here is a 0.8 approx, you can see here, or 0.75 you can see, up to, as it's a decreasing graph. It can be of any type as the data is given. After that we are going to get some values here which are allocate and targets we obtain. So here is another thing, that to reshape the shape techniques, or we are going to print the values here, and we use here, as you can see, the x scalar min max scalar function here to fit the transform, which is from the range -1 to 1 of x and y. Also you can see the both of them. After that we we are going to define the errors in the MXCT. So here we use the equation is equal to sum mx plus c minus t multiplied to power 2. So it returns another equation here. So if you get the output in the next iteration, you can see there we just use update here. We update the functions after that with the gradient descent, init m, init c, xt, learning rate, iteration, error, threshold. So we just use the loops here, and there's a condition if e is less than error threshold, then it will print the error less than the threshold. The stop gradient descent. Gradient descent basically used for the introduction where the error is greater than threshold value. Then we are going to here use our pen and update the values here. After that we are going to get the plot here where we uses the same equation as above for the slope, and here we get the scatter having the color G, which means for green, and color R, which means for red. As we can see here is a line, which is a stop line. It's of red color and the scatters of green color. Now we are going to plot the length and the error values, iterations, such that we see the iteration having text 0.50 iterations. So on the y-axis we can see the errors, on the y-axis we can see the iterations. Then from the taken equation we take the x test with the predicted values of y, which is generally the slope equation mx plus c. So we take the x test. So mean squared error is calculated here, you can see there. After that we just calculated the values of from the data frames of target y and predict y. So here we can see the difference of targeted value and the predicted value. After that we just use another plot which is of decreasing slope. As you can see, the scatter is of B, means blue color, and the predicted y and the x test values are in the G, which means for green color. As you can see here, the slope is of green color. So this is all which I was going to explain, and thank you so much.